Hello, there's different ways you can go about solving problems like these, but one of the ways that you can approach it is look at it as two fractions. And what you know from before is when you're dividing by a fraction, you can multiply by the reciprocal. And we have one fraction in my numerator, and you always leave that this just as it is if you're rewriting it. This is one technique you can use over 8x squared plus 8x. Change division to multiplication, and then your denominator, we're going to take the reciprocal of that. A lot of you say keep, change, flip, and that's exactly what I'm doing here. 4x squared plus 4x over 3 minus 3x. So then, when we're multiplying fractions, we do not need common denominators. So we can just multiply straight across. But when we have quadratics or higher polynomials in our numerator or denominator, you want to see if they factor first, because sometimes when they factor, we can get factors to cancel out. And if I factor the numerator and denominator, I have a greatest common factor of 6 in the numerator, and then I'm left with x squared minus 1. And then in the denominator, my greatest common factor is 8x. And then I'm left with x plus 1. And I have times my greatest common factor on the right side of my numerator is 4x. And then I have x plus 1. And then in the denominator, I have 3. And then I have a 1 minus x. So already I can see I have a factor of x plus 1 in my numerator and then in my denominator, and those cancel out. Okay, so now back over on the left side. I can factor x squared minus 1 more because that's the difference of squares. I'm going to do this step by step so you can follow along. I'm just copying down the 6, and then I'm going to have x plus 1, and then x minus 1. That's the difference of squares. I have 8x in the denominator because the x plus 1 canceled out. And I have a 4x on the right side over 3. And I'm going to switch the order. You'll see why in a minute. Negative x plus 1. Just to show you they're the exact same thing. All I did was switch the order of the 1 and the negative x. Okay. Now, the 6 and the 8, I can start reducing or multiplying across. It doesn't really matter. I could do this either way. If noticing I have an x in the denominator and the numerator, I can cancel those out. And at this point, we have a lot of numbers. We can say 24, 6 times 4 is 24. And then I have x plus 1, x minus 1, and then 8 times 3 is 24 as well. And then I have a negative x plus 1 here. 24s cancel out. So now I'm left with I just have x plus 1, x minus 1 in the numerator. And then I can it's like I want to cancel out, but my signs are different. So in order to do this, I can factor out a negative 1 out of the denominator. Because if I factor a negative 1 out of the denominator, this turns out to be x minus 1 here. And this is how we're canceling out the x minus 1s. We can take out one more factor. And then you're left with x plus 1 over negative 1, which is the same thing as negative x minus 1, which I believe was one of the answers on your page. This problem was from the review packet. And how we're going to start this is we are going to factor the numerator and denominator and then see if anything can cancel out. So when I look at the numerator, the first thing I notice is there's a greatest common factor of x. So before we do anything else, we are going to factor out an x, and then we're left with 2x squared plus 5x minus 3. And then in the denominator, it's just personal preference, but I like factoring when my leading coefficient is positive. So I like to factor out a -1. You don't have to. You can keep it as a negative x squared, but I just prefer to factor when it's a positive x squared. Either way, we should get the same answer in the end. So now we have two other quadratics, and we need to factor those. You can factor them at this point any way you want, but their factors you should get are 2x minus 1, and then x plus 3 in the numerator. And then in the denominator, we get -1. And then here's another quadratic we're going to factor, and we get x minus 2, and then x plus 3. Just as a little reminder, off to the side, 2x squared plus 5x minus 3. A way you can factor that is we can multiply the 2 times -3 and we get -6. And then I'm looking for factors of -6 that will sum to 5. And so I can think of it as a 6 and a -1. This is factor by grouping or split the middle. And then we think of it as 2x squared plus 6x minus x minus 3. And then I take the greatest common factor of the first two terms, and then it's 2x, and then I'm left with x plus 3, and then the greatest common factor of the second two, and then remember I want in parentheses to be x plus 3. That's where I end up with -1, and I have x plus 3. And then you group them together, and we get 2x minus 1, and then x plus 3. That's just simply if you needed a refresher on how I got this. Same thing could work with the x squared plus 6. X squared plus x minus 6, how to factor that. Okay, so at this point, we want to see if any factors can cancel out of the numerator and the denominator. We have x plus 3. They have to be exactly the same because you can only cancel factors out if they're exactly the same like that. And now we are left with x, parentheses, 2x minus 1, and then I have a -1, and then x minus 2. And that's as simplified as I can get. That negative sign, I can leave it out in front if I want and have x, 2x minus 1, and have x minus 2. That's equivalent. That's the same thing. Here's another problem from the classwork that has more fractions inside fractions. They're called complex fractions. And another technique we can do with these is if you don't know where to begin, just try to simplify the numerator and then simplify the denominator before you do anything else. So I'm going to look at that numerator, and we have x over x plus 1 and then plus 1. So we just have x over x plus 1. I'm just copying it. And then I know in order to add fractions, I need common denominators. So if I want to add a 1, I'm going to call that x plus 1 over x plus 1. That's just another way of saying 1. Anything over itself is equal to 1. That's my entire numerator. I just rewrote it, same exact thing. So now for my denominator, I'm going to also say if I want to subtract fractions, I need common denominators. I'm going to even write that over here. I'm just calling this x plus 1 over x plus 1. Same idea here. I need to have common denominators, so I'm going to make my common denominator x plus 1 here. X plus 1 over x plus 1. So now I'm going to have x over times x plus 1 over x plus 1 minus 1 over x plus 1. Okay, all we did was rewrite them with common denominators. So now on this problem, when we have common denominators, we can combine them together. So in my numerator, I have x plus x plus 1, and I'm all going to write it over the denominator just once. X plus 1. All over in my denominator. I'm just copying everything down. I'm not doing out any multiplication yet. X over x plus 1 minus 1 over the same denominator, which is x plus 1. Okay. Now I'm going to simplify these just a little bit. In my numerator, I have 2x plus 1 over x plus 1. And then in the denominator, I'm going to have x squared plus x minus 1 over x plus 1. There's different ways we can do this from here, but I want to complete this problem exactly like I just did the last one. And when we divide by a fraction, we can multiply by the reciprocal. So I'm going to take the numerator, copy it down exactly as it is, 2x plus 1 over x plus 1. And now instead of division, I'm going to write multiplication. I'm going to take the reciprocal of the denominator and say x plus 1 over x squared plus x minus 1. And we see that the x plus 1's cancel out. Some of you probably noticed that in the step before, and that's fine. So now we're left with 2x plus 1 all over x squared plus x minus 1. And that does not factor.